Okay, everyone, so we've looked at the reaction orders and all the integrated rate laws. So they're summarized here in this table. So all the way from 0th order to first order to second order. And if you go and rewrite them a bit, if you rewrite them a bit, you can see that they can all have the form of y equals mx plus b. In other words, you can write them in the form of a straight line. Why is that useful? Well, if you were to, for example, want to measure something or these reactions experimentally, then measuring reaction concentration or reactant concentration experimentally and then fitting data to it will tell you whether or not a reaction is 0th order, first order, or second order, or behaves according to first or 0th, first, or second order kinetics. And that's where this becomes quite useful. So meaning, if you want to know whether or not something behaves according to 0th order kinetics, you need to go and plot RT, right, against time, and then you should get a straight line, and the straight line will have a slope equal to minus k. If you want to know if something is first order, then you must plot according to this equation. You must plot ln of RT against time. So notice all of these have kt, 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 so that's why you choose time for the x-axis in each case. Should give you a straight line, and its slope will also give you minus k. Because again, its mx is minus k, mx was minus k. And in the final case, if you want to know whether or not something is second order, you must plot 1 over RT, and its mx, so its slope is going to be plus k. So second order, you plot 1 over concentration RT against T, and this graph looks something like that. And your slope is going to be plus k. So you go to the lab and you measure your reactant concentration over time, and then you plot it. And then you see which one of these three graphs, if you plot this data, then you see which one of these situations fits the data the best. And then you know which order your reaction is. Yeah, it's kind of neat. So this table just basically summarizes the information. So it means if your 0th order, so the rate equation for a 0th order, the integrated rate law, and what you need to plot. So what I drew here, so RT versus T, and then what your slope will be. Your slope will correspond to negative K, and for each of them. So you can just remind yourself of these little facts. So what you need to plot in each case, you don't really need to remember it. You just need to remember what equation corresponds to what rate law or what order of reaction, and then from that you should be able to infer what the straight line should be, so meaning what you need to plot against what, and what the slope should be. And remember, you always need to remember what the k units will be, because you might get a question that asks you, here are three graphs, this one fits the best, hence what is the order of this reaction? So it's all about the data fits which plot the best, and that indicates to you or infers to you what order of the reaction is the best. Okay, so that's how we can use the integrated rate laws to our advantage. Cool. That's all we're going to do about this section. So I don't think you have to plot the data yourself. The textbook gives some more information about it if you want to see how they actually plot it. So you can read that section for yourself if you want more. Cool. Thank you for watching.